So friends, we shall solve one example in order to understand the equilibrium of beams. So here in this example, we would like to find out the support reaction of a beam. So question is, find the support reaction of the given beam as shown in the figure. So I would like to show you the beam, the loads acting on the beam and the support condition of the beam. So we have a beam AB, and beam is a simply supported beam. So for this beam, we have got a point support at point A and the point support at point B. So we have got a simply supported beam here, and there are point supports acting at point A and point B, and there are two forces acting. The forces are the point loads acting at point C and point D in between. So we need to find out the support reaction. So if you look at this particular question, we know that the beam is simply supported beam. There are 2 point supports provided at end A and end B. And there are two forces acting at point C and point D having value magnitude 50 Newton and 75 Newton respectively. It's a very simple example. We just need to find out the support reaction. As far as solution is concerned, we first draw the free body diagram of the beam. So if you look at here, the free body diagram will look like very similar to the question itself. We have point A here, point B. So now at point A we have support reaction, we call it as RA, and at point B we have support reaction, we call it as RB. So question is very simple. So in this particular beam we will get support reaction at point A, we get support reaction at point B. Now so this is a simple free body diagram we can say. Now in order to find support reaction we have to use the condition of static equilibrium. So by condition of static equilibrium of beam, so what is the condition of static equilibrium? The first condition is the summation of forces acting on the beam in the horizontal direction. We can say x direction is horizontal direction, the y direction is a vertical direction. So summation of forces in the x direction, that is all forces acting on the beam in x direction must be balanced. But here there are no forces acting in the x direction, but second condition is important. The summation of forces in y direction, that is vertical forces, must be balanced. So that is summation of Fy equal to 0. So when I follow summation of forces in the y direction, so we have to follow some sign convention. All the upward forces we call positive and all the downward forces we call negative. That is sign convention we are going to take. Ra is acting upward, so it will be Ra, so it is plus because it is acting in the upward direction. You can take any sign convention, you can even take upward as negative, but then downward would be positive in that case. So we have taken upward as positive here. 50 Newton is acting downward direction, so it is minus 50 because it is acting downward. 75 is acting downward, so it is minus 75, and then again RB acting upward plus RB, so this is going to be 0. So we have followed the summation of forces in the vertical direction equal to 0, and then if you simplify this you get RA plus RB equals 50 plus 75 is going to be 125 Newton. So this is the first equation we got. Now we can also get another equation from condition of equilibrium. So summation of moment of forces. Whenever we take moment of forces, the moment of forces must be taken about a point where unknown quantity is acting. Like here at point A we have RA and at point B we have RB. So in order to simplify this, we should take moment of forces about point A or about point B. Please remember, we are going to follow a sign convention here, that the clockwise rotation, clockwise moment would be taken as positive, while the anti-clockwise moment would be taken as negative. This is simple sign convention. You can take opposite of it also. Okay, so now if you look at here, we are taking moment of forces about point A. So we shall be keeping point A fixed and will allow the beam AB to rotate about point A due to application of moment. So if I keep point A fixed and apply 50 Newton force at distance 20 meter, so beam is going to rotate something like this in the clockwise sense. Okay, so the moment of force 50 Newton about point A is going to be 50 into 22 meters, and that is clockwise. So clockwise we take positive, so plus T into 2 clockwise. Similarly, due to application of 75 Newton force, the beam is going to rotate about point A. Again, due to that, the beam is going to rotate in the clockwise sense like this. Please remember, we have to keep beam pivoted at point A and it is going to rotate due to application of 75 Newton. So 75 Newton and distance of 75 Newton from point A is going to be 2 plus 3, that is 5 meter. Again beam is rotating clockwise, 75 times 5, again clockwise rotation, and due to application of RB, beam is going to rotate in the anti-clockwise direction, so it will be minus RB times, and distance of RB from point A is going to be 2 plus 3 plus 2, that is going to be 7 meters, and that is equal to 0. Okay, so now if you simplify this, you'll be getting 7 RB equals 50 into 2 is 100, and 75 into 5 is going to be 375. That would give you RB equal to 475 divided by 7. That value will turn out to be 67.857. So when you substitute the value of RB in equation 1, you will get 125 minus 67.857 going to be 57.142 Newton. This way we got the value of support reaction RA and RB. Thank you.